Hi everybody, we continue to review calculus 1. On this one we have indefinite integral. Is the integral where we don't have the limits. Right. On here we just use the power rule. When we use the power rule, it is better if we write the constant or the coefficient in front and then the power of the variable later. So we write 1 over 7 t dt. It's better to write like that. And then we just apply the power rule. Just write the integral of t squared. Integral of t squared is t cubed over 3. And integral of t, or t to the first power, is t squared over 2. And then all the coefficient will stay. And the sign in the middle will stay. This is indefinite integral, so we will plus c. Right, and rewrite this. We will have, we can write t cubed over 12, or we just keep 1 over 12 t cubed, and 1 over 7 times 1/2, so 1 over 14 t squared plus c. Right. The next one is kind of the same. We will rewrite that. Again, we write the coefficient first, so it's 1/2 square root of y, and then 4 1 over square root of y dy. Right. And we have 1/2 square root of y. We can write as y to the 1/2 power. And 4 1 over y to the 1/2 dy. Right, and bring the y to the 1/2 from the bottom to the top. That turn to positive. So we'll have integral of 1/2 y to the 1/2 plus 4 y to the negative 1/2 dy. Once again, we applied the power rule. Y to the 1/2 is y, 1/2 plus 1 is 3/2. And then I should say plus 4, and then 1/2, all the coefficients stay, and then negative 1/2 plus 1 is 1/2 plus c. That's kind of difficult to see, so that's the first problem. So multiply reciprocal. We have 1/2 times 2/3 y to the 3/2, and then 4 times 2 y to the 1/2 plus c. So we have that cancel out 1/3 y to the 3/2 plus 8 y to the 1/2 plus c. So pretty much just the power rule. One thing to note, the notation, the integral sign and the dy goes together. Inside is called the integrand. When we integrate, the integral sign and the dy disappear at the same time. Right. This one we don't have to rewrite anything. We just integrate cosine of t. Integral of cosine of t is going to be sine t. And then the negative 7 will stay in front of it, plus c. and that's all we do. Sorry. Yeah. So cosine of t, integral sine t, and then the negative 7, and then plus c. All the indefinite integral will have the constant at the end. That will give us all the antiderivatives of the negative 7 cosine of t. Next we have a trig function. There is no product rule or quotient rule in integral. So what we do is we have to simplify it first. So I'll multiply it out. Sine theta cosecant theta now sine theta cotangent is cosine over sine, and cosecant is 1 over sine. So cancel the sine. We just have cosine plus 1. And then integral cosine is sine. And integral of 1, integral of constant, we're just going to stick a variable to it. So we just have sine plus theta, sine theta plus theta plus c. Right, so just very straightforward integral. There's no substitution here. It will be on the next test. Right. Next we have the initial value problem. Initial value problem is we're going to have the derivative integrated, get us back to the function, and then we have the initial condition. This is called the initial condition. And the initial condition will help us to find the constant c. Right. Get back to that at the end. For now, if we have the derivative, to get back to the function or the antiderivative, we just integrate. So derivative go back to y, we have to integrate. And integral of that, just the power rule, 2 times x negative 3/4 plus 1 is 1/4 over 1 over 4 plus the constant c. Now divide by 1/4 is multiply reciprocal, 4 x to the 1/4 plus c, or ax to the 1/4 plus c. Right, so that is the function. In general, that's what we have. Now we are given the initial condition, y of 1 is equal to 9, meaning that if we put 1 in for x, it will equal to 9. And obviously here 8 times 1 to the 1/4 is just 8, plus c is equal to 9. So c is equal to 9 minus 8, so it's 1. Now we know c is 1, we can substitute back into that. So the solution is y equal to ax to the 1/4 plus 1. So the initial condition helps us to find the constant c. With that we have the particular antiderivative that satisfies the initial condition. next we also have another initial value prompt, but in the form of an application prompt. So we have the velocity, which is the derivative of the displacement given in this form, and find about the displacement over time from t equal to 3 to t equal to 7, given that s is equal to 2 when t equal to 0. So we have s up equal to 2 when t equal to 0. So that is the initial condition. Let's write it out. Initial condition when t equal to 0, s equal to 2. Right. Now, we start with the derivative. Is equal to 9.8 t minus 5. So that is the derivative. To get back to the displacement, we'll integrate. And that gives us 9.8 t squared over 2 minus 5t plus c. 9.8 divided by 2 is 4.9 t squared minus 5t plus c. Right. Next we have the initial condition when t equal to 0, s equal to 2, and we put in this t equal to 0 and the whole thing will equal to 2. So we have 4.9 t 0 minus 5 times 0 plus c, and that is equal to 2 here. Right, so from here obviously c is equal to 2, and that we substitute into this c. So we have s equal to 4.9 t squared minus 5t plus 2. Right, and displacement, the position at t equal to 3, if we put 3 in here, I'll use a calculator for that. So we have this function. Wrong. Let's move the calculator only. Screw that. Right. So first I will store the 3 into t, or I use x instead of t. So we store that into the variable, and then we have 4.9 times x squared minus 5x plus 2. So we have s of 3 is equal to 31.1, and then we do the 7 store into x, and then go up, highlight the equation, and copy and paste. Just hit enter and it will copy and paste down, and that's 207.1. And then the displacement, so we're just going to subtract these two. Again, the calculator, if we highlight the numbers, subtract that, and that's 76. So s of 7 minus s of 3 is 176. So the difference in position from 3 to 7. Right. Next we have a couple of random sum problems. I'll let you do number 80. We'll go to 80. I'm only do 81 here. Right. So we'll go from 1 to 5 and divide that into 4 rectangles, and we use the left hand pawn. So just generically, I'll just go from 1 to 4, 1 to 5. I'll draw the number line. We don't have to draw the graph of the function, just draw a number line. That go from 1 to 5. And so we'll divide this into 4 equal segments. And obviously that had to be 2, 3, and 4. Right. So 1, 2, 3, 4 rectangles. Next, let me change the contrast. It look a little off. I think that's the wrong camera. I think that's a little bit better. Anyway, not by much, but it's okay. Alright, so from 1 to 4, if you want to find the width, it's going to be b minus a over n, and we have 5 minus 1 divided by 4, so the width of one rectangle is 1, and we use delta x for the width. Right. So the width is 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and for each one of them, for the first one, we use the left hand pawn, and then we calculate the height, which is the values of the function based on the left hand pawn, which is f of 1. That gives us a rectangle. The next rectangle, 2 to 3, we're going to use the left hand pawn at 2. If we have the graph is completely different, and the height is f of 2, and then from 2 to 3, from 3 to 4, we use the left hand pawn and f of 3, and then the last one also the left hand pawn, that f of 4. So the area of those 4 rectangles is delta x, the width, times the height for the first one, plus delta x times the width, the function at 2, plus delta x times the width, the function at 3, and then the width times the function at 4. Factor out the delta x. We have f of 1 plus f of 2 plus f of 3 plus f of 4. The width here is 1, so we just have add all of this up. Since delta x is equal to 1, that is just 1, so we just add all the function values. Right. If we use the calculator, it will help. Right. First we enter the function 1 over x squared, and now we just find the values, the function values at this point. Second quick, y equal to its variable, y variables, and a function, and then we evaluate from 1 to 4. So just say open parentheses, second parentheses, open the bracket, 1, 2, 3, 4, close. And that is the values of the function. It doesn't matter. We keep a fraction, the decimal like that. Next, we're going to add them up. So hit stat again. Sorry, second stat. Go to math. Option number 5, and we just add this list. Again, we cannot do that, so we add that list, and that is 1.423. Let's try 3 decimal places. Right. So that pretty much. That's what we have. Again, we find the width for each rectangle, and on this one we use the left endpoint. So we just use the left endpoint to find the height. The width is 1, so the height times the width give us the area of one rectangle. Since all the widths are equal, we can factor it out, and the width equal to 1, we just take that away, and so that's what we have. This one just a summation. If we do this by hand, we just want to put 1, 2, 3, and so we have 1 square minus 4, the first one, 2 square minus 4, the second one, and then 7 square minus 4, the last one. So if we want to do the summation, it's going to be math. Option number should be somewhere down here, and we just say x equal to 1 up to 7 x squared minus 4. Right. So it's not much there. 112. Of course, we just do this manually, and we also have 112. It's something that small, we don't need to use the formula for the summation. Right. Next, we have we use the geometry to find the integral. Right. Notice that this is the integral and not the area. So 83 and 84 times 10. Right. Now, I'm going to draw this function y equal to x minus 2. So make a little table. X minus 1. When x equal to 2, 2 minus 1 is 1. When x equal to 6, 6 minus 1 is 5. So we go from 1 to 5. When x equal to 2, y equal to 1. And when x equal to 6, y equal to 5. So pretty much we will find the area that is from 2 to 6. This area. Right, so to do that, okay, we'll cut this into a rectangle and a triangle. Since we go from 2 to 6, this side is 4, and here from 1 to 5, take away 1, we're going to have 4. So this triangle is the area 1/2 base times height. So that's going to be 8. And this rectangle is 4 length times width. So it's 4. And the area, since all of this area above the x-axis, so it's going to be 12. Actually, the area is always positive, but if the region is above, the area will be equal to the integral. So we have 2 to 6 x minus 1 dx. So the answer is going to be 12. Right. Of course, if we want to confirm with the calculator, hit math number 9 from 2 to 6, or just do it by hand. But do it by hand is the next part of the section. Right, so we have that. Next we have absolute values of -1. Absolute values is a v, so I'll draw the v. And then we want the area from the integral from -1 to 5. So we have this triangle, and then this triangle. So this triangle is 1/2 base times height, so that's just 1/2. And that bigger triangle, 1/2 base times height, so that's 25/2. Now both of these above the x-axis, so we just combine them. 1/2 25/2, and we add them. So that will be 26/2, which will be 13. And once again, because all of the region above the x-axis, so the integral will be equal to the area. If anything below, that will have to take the negative values. But on here we just have 13. If we want to do confirm with the calculator, math number 9 from -1 to 5, and I put absolute values. Math, go to second tab, absolute values of x dx. So that's, then we have 13. The calculator used approximation, so that's why the little off at the end, but we have 13. Right. Next, use this to evaluate the integral. Once again, I will not emphasize enough. This problem want the integral. Let me write the timestamp first. 25. Right. So this is integral and not the area. So if we want the area from A to C, we're going to add 5 to 4. That is 9. But this one want the integral. The notation, let's forgot the dx there. Should be whatever the area above is going to be positive 4, and area below. So that's going to be -1. Again, the integral from A to C, and this area is below, so the integral will take the -5 values, and this one above will take the positive 4 and -5. Either 4 and -5 or 4 minus 5 is going to be -1. Again, the integral can take negative values. The area cannot be negative. Next we have properties of integral. Right. I suppose that f and g are continuous from 3 to 7 equal to -2, and 3 to 7 is g of x. F of x is -2 and g of x is 9. So the only difference here is f of x and g of x. The limits are the same. So first, if this is the case, we can always split the integral. Where we split the integral, we have two integral signs. Therefore that integral and dx, and then integral and dx. I can take the 4 outside as well. Therefore, 3 to 7, the integral is -2. And the integral from 3 to, I don't know why I write 9 there. The integral is equal to 9. So that -8 plus 9, so it's going to be 1. Right. Next we want the integral from 9 to -1. So look at all of, first -1 to 9. Right. -1 to 9 of h of t dt. Right. We are not given from -1 to 9. We're given from -1 to 2 and then from 2 to 9, which is fine. We're just going to add them. So we can go from -1 to 2 first. And x and t really doesn't matter. And then we can go from 2 to 9. H of t dt. And -1 to 2 is 2. And 2 to 9 is -8. So it is equal to -6. So if we want from 9 to -1, which means this the limits flipped from 9 to -1. Then I just negate. When we interchange the limit, we throw in the negative sign, and that's just negative of -6 is +6. We skipped 88. That type question will not be on the test. In fact, we're going to do that in class. Now we go to 89 and 90 for the summation. Right. Very important on 89 and 90. This type of question asks for the area not integral. Right. So in that case, this region that is above the area is equal to the integral from 0 to 2 and the function is 4 minus x. 4 minus x squared dx. Right, just get the values here. Math number 9 as integrate from 0 to 2. We just use a calculator here because this is just a concept to distinguish between the area and the integral. We have a few problems where we use the fundamental theorem calculus to find the integral. Right, so that is convert to fraction 16 over 3. That area is above the integral equal to the area if the region is above the x-axis. Now if it is below the integral from 2 to 3, 4 minus x squared dx. Right, let's do that again. Actually, I just copy this one and we'll change the limit. From 2 to 3, and you see that is going to be negative. So remember, the area cannot be negative. so we have to throw in an extra negative. So if the region is below, the area and the integral have opposite signs. If we want area, it's going to be positive. If we want integral, it will be negative. The bottom line is this is negative 7 over 3. Negative 7 over 3 to just 7 over 3. And finally, we just add this two, so the total area is equal to 16 over 3 plus 7 over 3, 23 over 3. Yeah, remember, this one we want the area, not a definite integral. Right. Similar on the next one. Potentially, if we have to do it by hand, if we want to. Right. This region is above, so the area is equal to the integral. Here is 9, so we go from 9 to 16. The function is square root of x minus 3 dx. Right, let's do that. We might not have the nice and even answer because of the rounding error of the calculator. Math number 9. Let's go to 9, from 9 to 16 of square root of x minus 3 times dx. Right, that's good. That's 11 over 3. Right, so that is the area that is above. Now the area that is below. If the area is below, the area and the integral have opposite sign. So if we want them to be equal, we have to throw in an extra negative sign. So to 9 square root of x minus 3. Again, just copy that integral and now change to 0 to 9. Right, there's some error there. The answer is supposed to be come out negative 9 even. Right. If it's not the case, then we just have to do it by hand. It's perfectly fine. Square root of x over x to the 1/2 minus 3, and integral of that is negative x to the 3/2 over 3/2 minus 3x. So that is the antiderivative. I choose c to be 0, and then we let x equal to 0 to x equal to 9. Notice there's a negative here. So that gives us negative 2 over 3 x to the 3/2 negative and negative plus 3x from 0 to 9. So this I think we can evaluate by hand by the calculator. So first I'm going to put in 9 store into x, and then we have negative 2 over 3 x to the 3/2 plus 3x. It's going to be 9. So put in 9. And then we sub in 0. Subtract the values of the function at those limits. Of course, this we calculate in the calculator. We have 9 already. This we just have 0. So 9 plus 0 is 9. And finally, so this actually is equal to 9. And when we add 9 and 11 over 3, 9 plus 11 over 3. Convert this fraction, it is 38 over 3. And that is the total area. Again, the area, if the region is above, the area and the integral are the same. If the region is below, the area and the integral have opposite sign. The area must be positive. The integral could be negative. Right. Now we have definite integral. Right. It's just fundamental theorem of calculus. Let me write that out. Fx dx from a to b is equal to any antiderivative x equal to a to x equal to b. Right. So first, it is easy to integrate if we have x in the power. So we can use the power rule. X to the 3/2 over 3/2 from 0 to 9. Again, definite integral, where we have the limits, there will be no constant c, because here we have any antiderivative and we can choose it to be 0 to c to be 0. Actually, I should write this as f of b minus f of a, which is the same as this notation. Right. So rewrite this 5 times 2/3 x to the 3/2, all of that from 0 to 9. So that gives us 10 over 3 x to the 3/2. That goes from 0 to 9. Now we have 10 over 3, 9 to the 3/2, minus 10 over 3, 0 to the 3/2. 9 to the 3/2 is 3 square. Quickly, 9 to the 3/2. 9 is 3 square times 3/2. 2 and 2 cancel out. 3 cubed is 27. So we have 10 over 3 times 27 minus, that is 0. 27 and 3 cancel out. That's 9. And we have 90. That's all we do. Next, there's no chain rule in antiderivative integral. The only rule we have up to this point is the power rule and on the trigonometric function. Right. So I have to multiply this out. A square is multiplied by itself. And there's a typo in the problem, should be t. Right. T times t is t squared. T is times 1 over t is 1. 1 over t times t is also 1. And 1 over t times 1 over t is 1 over t squared. Right. So we have t squared plus 2 plus 1 over t. I will write t to negative 2 dt. Right. Now we applied the fundamental theorem of calculus. Integral of t squared is t cubed over 3. Integral of a constant is just t. And integral of t to negative 2 is t to negative 1 over negative 1. We go from 1 to 2. So we have t cubed over 3 plus 2t, and the t here moved to the bottom, which is negative, by the way. Just negative 1 over t. Excuse me. From 1 to 2. Right. Now we're just going to put in the values. It will be better if we just use the calculator here to store into t or x, and then we have x cubed over 3 plus 2x minus 1 over x and convert that to fraction. 37 over 6. So first we're going to put 2 in. So 2 cubed over 3 plus 2 times 3, 2 times 2, sorry, t is 2, minus 1 over 2. We put that in the calculator and we have 37 over 6. And then when we subtract, the case where we put 1 into it. Right, so just 1 store into x. And then just go highlight the equation, copy and paste, and that we can convert to fraction too. Right, so 4/3. But let's just write 1 cubed over 3 plus 2 times 1 minus 1 over 1. That is 4 over 3. Right, so pretty much we have that number minus this number, and that is 29 over 6. Yeah, so this one we just have to multiply them out. Right, the next one we have a trig function, integral of cosine is positive sign, and we just go from pi over 2 to 3 pi over 2. Right, so we have 11 of sine. We're going to put 3 pi over 2 in it. And then subtract where we put pi over 2 in it. Right, sine of 3 pi over 2 is negative 1. So 11 times negative 1. And then minus 11. Sine of pi over 2 is 1. So we have negative 22. Right. Next, we have integral of cosecant square. Integral of cosecant square is negative cotangent of x. Negative cotangent of x. And of course there's a 5 in front of it. And then we integrate from pi over 4 to 3 pi over 4. Right. So, and we just put in the values 5. Actually, I will rewrite this as negative 5 cotangent of x. and from pi over 4 to 3 pi over 4. From negative 5, cotangent of 3 pi over 4 minus negative 5 cotangent of pi over 4. Right. The cotangent values, we just use the tangent, the reciprocal, which is tangent, or we just say 5 cosine over sine. Negative, that's the plus 5 cosine pi over 4 and sine of pi over 4. Right. Cosine of 3 pi over 4, that is square root of 2 over 2, but negative. Sine of 3 pi over 4, also square root of 2 over 2, but positive. And then 5 square of 2 over 2, square of 2 over 2. So pretty much we have negative and negative. So it's going to be positive 5, and square of 2 cancel square of 2. So just 5. Same thing here. So that's going to be 10. Right. Next, find the derivative. Right, so we have derivative of the integral. So this is the other part of the fundamental theorem of calculus. In general, I will write out the formula first. If we want to integrate, if we want to differentiate, take derivative of, let's say, from g of x to h of x of the function f of t dt. So we won't take any integral, don't integrate. All we do is just substitute h of x into it, the upper limit. But then by the chain rule, we have to take derivative of it, and then subtract where we put in the lower limit, and then the derivative of that. So first, we don't integrate anything. That is because we have the derivative. So all we do is just put the square root of x in this. And then we have the derivative of it. And then we're going to put in the lower limit, but we have to subtract first. Put in the lower limit, and then derivative of that limit. Right. Since 1 is the constant, derivative is equal to 0, so all of this gone. Right. Now, 16. X square root of x I write as x to the 1/2 to the 9 power, and square root again I write x to the 1/2. Don't forget we still have the derivative. That gives us 16. X to the 1/2 times 9, x to the 1/2 to the 9 power. So 1/2 times 9 is 9/2. Derivative of x to the 1/2 is 1/2. X to the minus 1/2. Now 16 and 1/2 give us an 8, and x to 9/2 and x to negative half. When we multiply them, we add the powers. So 9/2 minus 1/2, combine the powers, give us 8x to the 4th power. Right, and then we have the average values of the function. Oh, sorry, haven't done this one yet. So this is the same thing. We're going to substitute in the limit, and then times derivative of the limit. This is constant, so derivative is equal to 0, so the whole thing go to 0. subtract, I will put in the lower limit and then derivative of that. So x to the 6, we have cosine square root of x to the 6 is x cubed. That's still negative, right? And then 6x to the 6 is 6x to the 5th. To rewrite, it's better to write this in front. So negative 6x to the 5th cosine of x cubed. So that's what we have. Right. Next, average values of the function. So average values of the function, average values of the function is equal to 1 over b minus a. From a to b, the integral of fx dx. So in this problem we have b is 5 and a is negative 2. We go from negative 2 to 5. 2 minus x squared dx. Right. So give us 1 over 7. Integral of negative 2 to 5. 2 minus x squared dx. So we have 1 over 7. Integral of 2 is going to be 2x. Integral of x squared is x cubed over 3. All of that go from negative 2 to 5. Right. So actually we could just keep the 1 over 7 and then we just evaluate this. Right. First we're going to put 5 in. And then we put negative 2 in. Right. So I will use the calculator again. This is a function. Put in 5, put in negative 2. So 5 store into x. And then we have this function 2x minus x cubed over 3. Let's convert that fraction. Negative 95 over 3. So we have 1 over 7. Negative 95 over 3. And minus. Right. Now we have negative 2 stored to x. And then the same function, negative 4 over 3. Right, so 1 over 7. So we have these values minus these values is negative 91 over 3. And we have that times 1 over 7. And we have negative 13 over 3. Right. So of course we can do all this by hand, but I'm running out of space. But anyway, so that will be it for this part of the review. I hope you found this helpful. Thank you for watching.